Okay, here's part two of multi-step equations. I decided to make a part two because I thought that just stopping with fractions might be a little bit premature. So let's go ahead and try another different kind of problem, because in the last problem we got to use the addition property of equality to add two quantities to both sides, and then we got to use the multiplication property of equality. But let's try one where we have to actually deal with negative numbers. So we're going to actually, instead of using the subtraction property of equality like last time, we're going to use the addition property of equality. So this is problem number 30 on page 72. So in this case, we have, again, fractions involved. And instead of getting scared of the fractions, let's go ahead and think of this as we did before. On the one side, on the left side of this equation, we have negative 1/5 of a quantity, and to that we're adding negative 2 of a constant quantity. And we say it's a constant because it doesn't have a variable. It's always going to be negative 2, whereas this quantity here is always going to change depending on what the variable t is. And so we have that on the left side, and on the right hand side we have 4. And so we know that whatever t is equal to, that those two are going to equal 4. So let's go ahead and write this algebraically. If I were to go ahead and write this as an algebraic equation, on the left hand side we would write, we have negative 1 over 5 t, and to that we are going to add a negative 2. And I'm going to write plus negative 2 just so that we're clear what we're doing. Let me actually make the t, let me put a little squiggly at the bottom of the t to differentiate what the t is and the plus sign is here. But this is how we're going to write it. What I think how the book gives it to you is actually negative 1 over 5 t minus just 2. But we covered in class that when we're subtracting two real numbers, that a good way to think about it is we like to convert this to an addition problem. And how we convert a subtraction problem into an addition problem algebraically is we're simply going to add the opposite of the number. And so in this case, we're going to change this to an addition, and we're going to take the opposite of 2, which is negative 2. And of course, this is equal to 4. So we have this algebraic version of what we have on the scale here. We have negative 1 over 5t plus negative 2 is equal to 4. Now, in the last example that we had, we actually subtracted a number from both sides, because essentially what we're trying to do is we're trying to move this entire quantity away. And so we wanted to do something to both sides of this equation that would set it equal to each other. We wanted to keep the scale equal to each other. In this case, if we subtract, if we add, or if we subtract negative 2 on both sides, it would merely add more weight to both sides. So what we have to do is we have to actually add the opposite of this in order for us to isolate just this first negative 1 over 5 t. And so if we add a positive 2 to this side, and if we add a positive 2 to this side, oops, my 2 didn't come out too well. What we're essentially going to have on this left-hand side is negative 1 over 5 t. And since we added the opposite of negative 2, we added positive 2. Now, negative 2 plus positive 2 is 0. So now we've isolated the variable on one side by itself. What do we have on the other side? Well, we have 6 now. And so we have negative 1 over 5t is equal to 6. So we were successfully able to take away this negative 2 from both sides of the equation by adding a positive 2. I know it seems a little counterintuitive, but that's what it is when we're adding, when we're dealing with negative numbers. And so now we're left with negative 1 over 5t on one side and 6 on one side. And a lot of people get confused at this point because they'll start trying to add a positive 1 over 5t. However, that just won't work, because the operation between this negative 1 over 5 and t, the operation that is binding these two together is actually multiplication. And so what we actually have to do is we can't add to break up that bond. What we actually have to do is multiply by the reciprocal of negative 1 over 5 so that we can get t by itself. So if you want to pause just to quiz yourself, what is the reciprocal of, or the inverse of, negative 1 over 5? So I'll let you go ahead and pause the video. And if you're back, here we go. Here's the answer. The inverse of negative 1 over 5 is simply negative 5 over 1. And again, just like we talked about in the last video, the reason why we multiply by the reciprocal is because we're trying to get it so that t, the variable, is on one side by itself. We want this t, this right now, because right now it's negative 1 over 5t. We want it to be 1t. And we know that if we multiply this by the multiplicative inverse, like we talked in class, that we would end up with 1t. Because when we multiply, I should do this actually because it looks like we're subtracting those quantities. But when we multiply negative 5 over 1 times negative 1 over 5, we are going to get 1. Because just like we talked about in class, a negative times a negative is going to be a positive. But let's go ahead and simplify this. If 5 times 1 is 5 and 1 times 5 is 5, we can, those two simplify, and what we end up with is 1t on one side. And on the other side, we have this 6 times negative 5 over 1, because that, this is the multiplication property of equality at work. Whatever we do to one side, we also have to do to the other side. And again, if you're still having a little bit of confusion with this, let's change this to a multiplication, or a fraction, which is 6 over 1. And so 6 times negative 5 would be negative 30, right? Because a positive times a negative is a negative. And then in the denominator, we have 1 times 1. And we can write it as negative 30, or we can write it as just negative 30 instead of negative 30 over 1. And so the answer we get is t equals negative 30. And we can test this out. If we plugged this negative 30 into the t here, we should get an answer that is equal to 4. Okay, so let's go ahead and try that where we have a little bit of space over here. If we have negative 1 over 5, and we multiply this by what we found out t to be, which was negative 30, and we subtract 2 from this, we should get 4. So let's go ahead and try that. I'm going to change this to a fraction so that we can more easily see what's going on when we multiply the fractions. And I'm going to put a grouping symbol here so we know that the operation that's happening between these two fractions is multiplication. When we have this, when we have a negative 1 times a negative 30, a negative times a negative gives us a positive 30. And in the denominator, we have 5 times 1, which is equal to 5. And we're going to subtract 2, and we should get 4. Let's go ahead and simplify 30 and 5. Let me change the color here so we can see the simplification going on here. When we simplify 30 and 5, how many times is 5 going to 30? Well, we know it's 6. Of course, once we've done that, this 5 becomes a 1. And so essentially what we'll have is 6 minus 2. And when we do that, 6 minus 2 is 4. And we know that 4 equals 4. Therefore, we have the right answer. Okay? So t is indeed negative 30. Let's try one more example before we call it a day. This time let's try decimals, because there were some problems with decimals in our extra credit homework over the weekend. And so here's the problem. I think this is problem number, it looks like problem number 32 from the book. So let's go ahead and try this. And essentially the concept is still the same. We have a coefficient with an unknown variable, and then we're adding to that a constant of 3.5, and those two things are going to equal 7.32. And so how we would write this algebraically is we would write the left-hand side first. So we have 10m, the variable m on one side, and to that we're going to add 3.5. 3.5. And that is equal to 7.32. Now, again, the idea is whatever we take away from one side, we're going to take away from the other side. This time we have a positive integer, and so we don't have to add a positive number. We're going to subtract from this. And so in this case, we're going to subtract 3.5 3.5 from one side, since the opposite of positive 3.5 is negative 3.5. And whatever we do to one side, we want to do to the other side. Here we have the subtraction property of equality at work. When we do that, we know that 3.5 minus 3.5 is 0, so I'm not even going to bother writing it. And we know we are on the right track because we have the variable and the coefficient on its own. And so we're almost one step away from finding out what the variable m is. And of course, when we subtract 7.32 minus 3.5, the number we should get is 2, 8, and then this would become a 6. 6 minus 3 is 3.82. And again, a positive 3.82 since the absolute value of 7.32 is greater. And then once we do that, we're one step away. So far we've been dealing with the addition property of equality, the subtraction property of equality, and even the multiplication property of equality. But here, for the first time, we're going to deal with the division property of equality, because we have a 10m, and to that, in order for us to figure out what m is, we're going to multiply this, or we're going to divide this by something in order to get m by itself. We want 1m. And so what we're going to do is we're going to divide 10 by 10. Because when we do that, 10 and 10 are going to simplify, and we're left with 1m. What we're looking for m. And so, of course, whatever we do to one side, we also have to do to the other side. And this should be fairly straightforward for us now if we understand the basics. I love dividing or multiplying by 10 because it's pretty easy, especially when we're dealing with decimals. When we have 3.82 and we're dividing by 10, all we really have to do is move over this decimal place one spot to the left, and the answer we should end up with is 0.382, and that's our answer. M equals 0.382.